Hi, welcome to my channel, JaberTime. Today I'm going to go over first order linear differential equations and the integrating factor, the use of it. And here's an example. We're going to go over this example down below. Let's get started. What is first order linear differential equations? It's first order. As you could see, it's the first derivative. It's not second derivative. And it's linear. They look like dy dx plus p of x, a function of x, multiplied by y equals another function called q of x. The function I of x, which is e to the integral of p of x dx, is called the integral factor. For the differential equation given to us, that looks like this. Since it enables us to reduce the differential equation to a form that is directly integrable. The derivative of e to the p of x dx multiplied by y. This is a product rule. I want to show you where the integral factor comes from and how it's used and applied. So if we apply the derivative of a product right here, we're going to use the product rule. Imagine if this is u and this is v, so we're going to go like u times v prime plus v times u prime. So we write them as u and v once we differentiate v and once we differentiate u. Derivative of y is y prime. Derivative of this function right here, we'll treat it as a function that looks like e to the u. Derivative of e to the x is e to the x. Derivative of e to the u is e to the u times u prime. We apply the chain rule. So here we go. E to the u times u prime. The derivative of u, as this being called u, is p of x by itself because the derivative of the integral cancels. Now, notice that both terms, they do have this expression or function, e to the power integral of p of x dx. It's written here and written here, so we're going to take it out as a common factor. So by taking it out as a common factor, we end up with inside y prime plus p of x multiplied by y. Now, this looks inside y prime plus p of x y as part of the first order linear differential equation, which was given to us as being defined to equal q of x. So we're gonna replace this, which is inside parentheses right here, with q of x. So e to the power integral of p of x dx times q of x is our answer. Let's connect the first part with the last part. Connecting them together, we have d dx of the product that we see right here gave us e to the p of x dx multiplied by q of x. Or that's if you integrate both sides, the d dx will cancel. We'll leave this alone, and this will show inside an integral, of course, with respect to x. So what do we have here? We have I times y equals integral of I times q of x dx. This right here will be called, in short, because it's kind of hard to keep saying e to the power integral of p of x dx, we just called it I. That's our integral factor. So I times y equals the integral of I multiplied by q of x dx, where I is e to the power p of x dx. Okay, that's where the integral factor comes in handy, and that's how we apply it. Now, how do we end up solving the equation? The first order linear differential equation looks like this: dy dx plus p of xy equals q of x, where I equals e to the power integral of p of x dx. I times y equals the integral of I multiplied by q of x dx. So if you want to leave y by itself, you get y equals 1 over I times the integral of I q of x dx. So that's pretty much what this section is about. The first order linear differential equations, they look like this. So you need to identify p of x and q of x. It has to be first degree of y, and that's going to be y. If this is a different function, that's going to also relate to it. We use the integral factor, and we end up with this. Or in short, you need y. To solve this differential equation, we need to take back y by itself, and that's how we do it. Let's start our example. Y prime plus 1 over x ln x multiplied by y equals 9x to the second. What is the integral factor? Well, we know that this is p of x and this is q of x. So we take p of x, integrate that on top of the e. That's how we get I. For this right here, we're going to use u substitution. So we're going to call u equals ln x, just these two right here, ln x. The reason why, the derivative of u will be 1 over x dx, which becomes in handy, 1 over x dx. Let's go back to the problem. I equals e to the power 1 over ln x, separating that from 1 over x dx. That is 1 over u times du, which shows right here. That's du, and that's 1 over u because u is ln x. That becomes e to the power ln u. The integral of du over u is ln u. Derivative of ln x is 1 over x. Derivative of 1 over u is 1 over u times, derivative of ln u is 1 over u times du. So, ln is the inverse function of e because it has the base e. Applying this twice, that cancels, and we get u by itself. And what is u? It's ln x. Okay, to summarize that, we came up with the following, which is a great step. Because once you identify I, find it, you're almost done. You just go back to the main formula, which is I times y equals the integral of I q dx. So I is ln x. I is ln x. We get to I times y equals the integral of I times q dx. Here's I, which is ln x, times y equals the integral of I, which is ln x, times q, which is 9x to the second dx. Let's take 9 outside the integral, and let's write y up front. So y ln x equals 9 times the integral of x to the second ln x dx. Now we need to handle this integral, and the way to do it is we're going to use integration by parts. U equals ln x, and dv is x to the second dx. We differentiate u, and we integrate dv. With that, we get the integral of x to the second, which is x to the third over 3, the derivative of ln x is 1 over x dx. So we multiply these two parts and we go back, subtract the integral of the product of these two terms, v and du. Here we go. 9 outside. The integral right here using the integration by parts. We get ln x times 1/3 x to the third. That's right there. Minus the integral of these multiplied, but 1x cancels with 1 from the x cube. Will leave you x to the second. We know how to integrate this. That's x to the third over 3. Another 3 in our way will give us 1/9. Now I used the constant of integration as k because we're going to modify it and we'll call it c at the end. Multiplying by 9 all over. 9 times 1/3 will give me 3. 9 times 1/9 will give me 1. So we have the following. This constant of integration becomes 9k. Let's call it c. That's for the convenience. And now we have y ln x equals this much right here. If you want y by itself, divide by ln x, and that should do it. 3x to the second ln x minus x cubed plus a constant of integration all over ln x. And that should do it. We're done. I have another example after this. This is about 13 minutes. So the second example is going to be about the same. Thank you for watching. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.